Today we have some exciting news to share with you. 5 ways we could travel interstellar in the future. But before we start, be sure to like and subscribe to the channel. So what is interstellar travel and why is it important? Well, to answer that, we need to know what interstellar means. Interstellar means between the stars. Our solar system is just one of billions of star systems in our galaxy, the Milky Way. And the Milky Way is just one of billions of galaxies in the universe. There are countless worlds and wonders out there, waiting to be discovered and explored. But there is a problem: space is huge, and stars are very far apart. The nearest star to our Sun is Proxima Centauri, which is about 4.2 light-years away. That means it takes light, which is the fastest thing in the universe, 4.2 years to travel from Proxima Centauri to us. And light travels at about 300,000 kilometers per second, or 186,000 miles per second. How can we ever hope to reach another star system, let alone another galaxy, with our current technology? Well, it turns out that there are some possible ways to make interstellar travel a reality in the future. Some of them are based on existing science and engineering, while others are more speculative and require new discoveries and breakthroughs. But they all share a common goal: to expand our horizons and explore the final frontier. Here are 5 ways we could travel interstellar in the future. 1. Nuclear rockets. Nuclear rockets are rockets that use nuclear fission or fusion to heat up a propellant and eject it at high speed. This gives them more thrust and efficiency than conventional chemical rockets, which burn fuel and oxidizer. Nuclear rockets could potentially reach speeds of up to 10% of the speed of light, or 30,000 kilometers per second. At this speed, it would take about 40 years to reach Proxima Centauri. Nuclear rockets are not just science fiction. They have been tested and developed since the 1950s, but never flown in space due to safety and political concerns. However, some scientists and engineers are still working on improving nuclear rocket technology and making it more feasible and reliable for interplanetary and interstellar missions. 2. Solar sails. Solar sails are thin sheets of material that reflect sunlight and use its pressure to propel themselves through space. They do not need any fuel or engine, only sunlight. Solar sails could potentially reach speeds of up to 20% of the speed of light, or 60,000 kilometers per second. At this speed, it would take about 20 years to reach Proxima Centauri. Solar sails are also not just science fiction. They have been demonstrated and deployed in space by several missions, such as Icaros, LightSail, and NanoSail-D. However, these missions have only used solar sails for orbit control or deorbiting purposes. To achieve interstellar speeds, solar sails would need to be much larger and lighter than current designs, and use powerful lasers or other sources of light to boost their acceleration. 3. Antimatter rockets. Antimatter rockets are rockets that use antimatter as fuel. Antimatter is the opposite of normal matter. It has the same mass but opposite charge. When matter and antimatter meet, they annihilate each other and release all their energy in a flash of gamma rays and particles. This is the most efficient way to convert mass into energy, according to Einstein's famous equation E=mc². Antimatter rockets could potentially reach speeds of up to 50% of the speed of light, or 150,000 kilometers per second. At this speed, it would take about 8 years to reach Proxima Centauri. Antimatter rockets are still science fiction, but not impossible. Scientists can create small amounts of antimatter in particle accelerators, such as CERN in Europe. However, antimatter is very hard to make and store. It costs billions of dollars per gram and needs special devices to prevent it from touching any matter and exploding. To power an interstellar mission with antimatter rockets, we would need to produce and store much more antimatter than we can today. 4. Warp drive. Warp drive is a hypothetical way of traveling faster than light by bending or warping spacetime around a spacecraft. Instead of moving through spacetime, the spacecraft would move spacetime itself, creating a bubble or a wave that carries it along. Warp drive could potentially reach any speed imaginable, even faster than light. At this speed, it would take less than a year to reach Proxima Centauri. Warp drive is pure science fiction for now, but not ruled out by physics. In 1994, a physicist named Miguel Alcubierre proposed a mathematical model of a warp drive that does not violate the laws of relativity. However, his model requires exotic forms of matter and energy that have negative mass and density, which have never been observed or created. It also requires enormous amounts of energy, more than the mass of the Sun, to warp spacetime. To make warp drive a reality, we would need to find or invent new forms of matter and energy and new ways of manipulating spacetime. 5. Wormholes. Wormholes are hypothetical shortcuts or tunnels in spacetime that connect two distant points in the universe. Instead of traveling through spacetime, a spacecraft could enter a wormhole at one end and exit at the other end, instantly or in a very short time. Wormholes could potentially connect any 2 points in the universe, even across different galaxies or dimensions. At this speed, it would take no time at all to reach Proxima Centauri. Wormholes are also pure science fiction for now, but not ruled out by physics. In 1935, Einstein and his colleague Nathan Rosen proposed a theoretical model of a wormhole that is compatible with relativity. However, their model requires exotic forms of matter and energy that have negative mass and density, which have never been observed or created. It also requires a way to keep the wormhole open and stable, as it would tend to collapse under its own gravity. To make wormholes a reality, we would need to find or invent new forms of matter and energy and new ways of creating and controlling wormholes. These are 5 ways we could travel interstellar in the future. Some of them are more realistic than others, but they all show that interstellar travel is not impossible, only very difficult and challenging. But with enough curiosity, creativity, and courage, we may one day overcome these challenges and explore the stars. That's all for today. Thank you for watching. If you liked this video, please give it a thumbs up, share it with your friends, and subscribe to our channel. And don't forget to hit the bell icon to get notified of our next videos. See you next time.